All right, so we're going to start section 5, constructing a function to model a linear relationship. So this is getting into a lot more of the applications and being able to write an equation of a linear model, same thing. This is the last section of this chapter, so let's get going. So example 1, at time, when t equals 0, a bicyclist begins riding at a constant speed. 10 minutes later, the bicyclist has traveled 2.5 miles. So we want to write a linear function rule that models the distance d the bicyclist has traveled after any number of minutes t. So I can do this multiple ways. I could get a graph the 2 points, write an equation based off the graph. That's one way. Or I can take what is in the information and work with it from there. So, too close to the mouse track. So I'm going to take, I have 2 points. I have the fact that we're starting at distance 0, right? And then I have that 10 minutes later, so at 10 minutes, we have traveled 2.5 miles. So I have found 2 points. And from 2 points, we can find the slope. So that's the first thing I'm going to do. We're going to use y minus y over x minus x. So for our case, that's going to be 2.5 minus 0 over 10 minus 0, which will give me 2.5 over 10, which leaves us with a slope of 0.25, because I'm going to do the division. And so this is my rate of change, right? Rm. And then from there, if we're going to be writing an equation y equals mx plus b, I also need that initial value. And so our initial value is going to be the fact that we're starting at 0, and that we haven't traveled anywhere. So our b value is going to be 0. From here, I'm just going to plug in y equals 0.25x plus 0. Now, because it's plus 0, our final answer will just be y equals 0.25x, or y equals mx. And that is our final answer. In the case of this one, it does say d and t, so really I should write this as d equals 0.25t. We all get in that habit of x and y, so we need to remember to double check if it's telling us to use other variables. And it's okay to write it with the x and y and then change to whatever variables it gives you. So yes, I used x and y, realizing though as I read the last sentence that we need to use d and t. So this is the more correct answer. All right, so other things to talk about, we could take, and from any of these, get information. So I can, any 2 points, create a line. So like on that last example, we had the point 0, 0 and the point 10, comma 2.5. Well, those together create a line with the slope of 0.25. So we're going to be working with the following points. Oh, there they are. We're going to work with the points -4, -2, and 3, 12. So here are 2 points. I can graph them, and from that graph I can grab information. I can use the 2 points and write my linear function rule. So remember, our linear function rule is y equals mx plus b. And so from 2 points I can find slope. And so that's the first thing we're going to do. We're going to find slope. M equals, I'm going to take 12 minus a -2 over 3 minus a -4. And so minus a negative means plus a positive. So I'm going to end up with 14 over 7, which equals 2. So right now I know that my m is 2. The one thing I don't have when I don't have the graph and I just have points is I don't have b. So what I'm going to do is I'm going to use m, the fact that m equals 2, and 1 point. So I'm going to choose the point 3, 12 just because they're both positive numbers and I don't have to worry about signs and dropping negatives. And from that I'm going to find b. So I'm going to plug in my y, so this is x and this is y. So my y is 12. So 12 will equal my m, getting ahead of myself, my m, which is 2, times my x, which is 3, and then plus b. So some of you may remember from chapter 7 in the study plans we had a problem about finding perimeter. And for a lot of you in that study plan, I said, okay, well, let's figure out for the first shape, and then we went down to the equation and we plugged 1 in and we solved for the missing piece. Well, that's what we're doing here. It's just more than just 1 in for our x. So I now have 12 equals 2 times 3, which is 6, plus b. So then I'm asking myself, 6 plus what equals 12? And either I can figure it out or I subtract 6 from both sides. And when I subtract 6 from both sides, b will equal 6. And so I know that m is 2 and b is 6. So now I can write my equation of the line in the form y equals 2x plus 6. And so that is the equation of our line. And if we look here, I mean, this was the same 2 points, so yes, we're going to get that slope of 2. So up 2, right? So from 6 to 8, that's 2. And over 1, because from 0 to 1 is 1. So we have that slope of 2, and then our y-intercept is right here at 6. So b equals 6. So you can use a graph. You just need to make sure that your line is very straight so you can find that y-intercept, or you can use algebra to find your y-intercept. So now we're looking at example 2. A jewelry store sells charm bracelets and charms. A bracelet with 2 charms costs $7.50 and a bracelet with 4 charms costs $9.50. Write the linear function rule to model the cost of the bracelet with any number of charms. So I'm going to make D be our cost, right? D for dollar, that's why I chose D. And C is going to be charms. And so I have 2 points given to me. I have that when we have 2 charms, it costs $7.50. And that when I buy with 4 charms, it costs $9.50. And so I'm going, again, you could graph this and write the equation from the graph. I'm just going to find m and then plug in to solve for b. So m is going to be $9.50 minus $7.50 over 4 minus 2. And so $9.50 minus $7.50 is going to be 2, and 4 minus 2 is 2, so that means our rate of change is 1, so m equals 1. I'm then going to pick a point, so I'm going to take the fact that m equals 1 and the point 2, comma, $7.50, and I'm going to plug into y equals mx plus b. And so y would be the $7.50 equals m, which is 1, times my x, which is 2, plus b. So $7.50 equals 1 times 2 is 2, plus b. Solve for b, we're going to subtract 2 from both sides. So $7.50 minus 2 is going to be $5.50 equals b. So what this tells us is if I buy just the bracelet with no charms, the bracelet itself costs $5.50. So that's what that initial value means. But we want that linear function rule. So we're going to replace y with d and x with c. And so we'll have D, our dollar amount, will equal 1 charm, so $1 per charm, plus $5.50. And so then that will be our linear function rule. And again, notice how here we have y equals mx plus b stuck in our head, but before I went and wrote my final equation, I took y and said, okay, well that's going to be my D, my dollar amount, and x is my charms. So when I go to write this here, that's how it's going to look.